Hello, Pre-Algebra students. All right, so that first video you should have watched kind of an example of how to make a prediction of a population or make a prediction based on a percentage given. So it was this kind of like a probability example, but we can use that in different contexts as well. It's the same exact principle. So just to repeat, well, to make a prediction about a population, if you have some percentage of a sample, you can make a prediction by taking that percentage and then multiplying it by the number of, well, whatever you want to find, the number of people in a population, for example. And that will give you your prediction, your predicted number of people. If you're doing a number of people in a population, your predicted number of people in a population, giving that response. So that would be a specific example when you're doing like a survey or something. So it might help to see another example again here. So we want to make a population prediction. There are about 105 million households in the United States. In a survey, 5,000 randomly selected American households, 780 of them watched a certain program. Of all the American households, how many watched the program? Well, the reason that we're doing this kind of thing is in this exact context right here. You obviously can't survey 105 million households, so what you do is basically just take a sample of that population and then use it and kind of spread it across and make an assumption about what the rest of the population would be like if you just take a small sample of it. So our sample of that population is the 5,000 randomly selected households. Okay, and it's good that they're randomly selected. That kind of helps avoid any biases or errors in that. All right, well, 780 of them watched a certain program. Of all the American households, that means of all the 105 million, how many can you predict watched the program? Well, first we want to figure out from this sample, if there's 5,000 that are selected, what percentage of them watched a program. Well, we can find that by just doing 780, that's how many watched the program, and then dividing it by 5,000. This should be kind of a reminder for finding percentages. Well, if you plug that in, you're going to get, you're going to get exactly 0.156, which you remember, move this decimal place 2 places to the right to get a percent. That's 15.6%. So just in that survey, 15.6% of them watched a certain program. The whole point of this is we can use that percentage to make a prediction about any population, or specifically about the 105 million households. So what we do is we take that percentage, 15.6%, and we multiply it, and leave it as a decimal. We multiply it by, well, how many households there are. There's 105 million, so 105,000. We multiply that out. You will find that you get about 16 million, I'm going to round, 16,400,000 households. So about 16,400,000 households out of 105 million households watch the program. So the whole point of doing this is we've been working with surveys and things so far. You can use a survey to make general assumptions about a population. Okay, now the problem with surveys is that they're not exact indicators of what's going to happen. We don't know for sure there's going to be 16 million for 400,000. It's a prediction. It's a somewhat accurate prediction based on information you've gathered from a sample. But there's still going to be a margin of error. And margin of error defines, it's just an interval that tells you basically how much the percent can fluctuate for this specific example. So in the previous example, we found that there was a 15.6% watch rate, right? 15.6% of people watch the program. Okay, well, if the survey has a 5% margin of error, really what we're saying is we're not for certain it's exactly 15.6%. Okay, we're not exactly certain it's 15.6%. It could fluctuate somewhere plus 5% or minus 5% from there. So it could be anywhere, and if you add 5%, you're going to find that, well, you could be 20.6% of the population, or we could be 10.6% of the population. So when you have a margin of error, when all surveys do, you're basically saying, well, we think that those surveyed are about 15.6% watched that program, but there's a margin of error. So really 10.6% all the way up to 20.6% of people could have watched that program. So there's really some fluctuation that could happen here. So how do you interpret this then? Let's move on to our last example here that we'll do. So, a survey of a random sample of voters predicts that candidate A will receive 52% of the votes. So candidate A will receive 52% of the votes, and candidate B will receive 48% of the votes. Okay, so right now you could probably predict, well, it seems like A is going to win. However, the margin of error is plus or minus 3%. So what we want to do is, well, can we predict who will win the election? And really the answer to that question is almost always no. Surveys, you can sort of predict, but what this is asking is the survey accurate enough? Is the survey accurate enough that we can confidently select a winner? That's basically what we're saying here. There's no way you can guarantee and predict, but we're making a prediction. Can we make a good prediction? So let's first just figure out what's the interval that A could possibly have for actual values in the population. So if we extrapolate this to the population, well, we know that about 52% of it, but there's a margin of error, so really we could have 52% minus 3, which would be, well, 49%. So really, we have a 49% vote rate to, we could possibly also have 55%. And B, candidate B's voters could fluctuate all the way from, well, 48 minus 3 is 45%, all the way up to, well, 48 plus 3 would put me at 51%. So it seems like you should be able to say, well, A, no matter what, is going to have more percentage of voters, so we should be able to assume that. But if we look at the extreme cases, there's going to be overlap. A can go all the way down to 49%, and B can go all the way up to 51%. Okay? So what's really going to happen here is there could be overlap. Since there's overlap in that percentage, since there is overlap, you can't confidently predict. You cannot make a confident prediction. You can't confidently predict who will win. And you can never 100% predict who's going to win, but I'll show you an example. Let's maybe just change this question. Let's say the margin of error, this is a really accurate survey, or there's very few errors. Let's say the margin of error was 1%. Well, if it was 1%, then A's percentage would then change from, well, it's going to fluctuate 51 to 53%. They're still getting a majority of the votes. And B would fluctuate, well, we'd start at 48, and that would either be somewhere from 47% all the way up to 49%. Okay? There is no overlap here. There's nowhere where B could have a percentage of voters that A could have. A is always going to be greater. In this case, we could say, well, A is more likely to win since there is no overlap. More likely to win since there is no overlap. There was overlap above here because A could be 51% and B could also be 51%. A could be 49%, B could also be 49%. There's a couple places where there's a little bit of overlap. In this example here, there would be no overlap, so you could make a prediction. So keep in mind how that changes if there's overlap and if there's no overlap. If there's no overlap, you can be more confident about the prediction. If there is overlap, you can't really make a prediction. That's kind of the summary of this type of problem. All right, that is all we're going to cover. Make sure you are hopping on those Zoom meetings, asking questions, getting your weekly participant participation points. Have a good day, everybody, and as always, stay safe out there.